Hi, welcome to today's webinar, Field Data Collection with iPhones, iPads, and Lasers. Today, geospatial experts in laser technology will provide an overview and demonstration of an integrated system that combines geospatial experts' GeoJot Plus and LTI's TruePulse 200X to streamline the collection of photos, data, and laser measurements. In addition to capturing the data, we will also demonstrate how the GeoJot Plus system allows the user to edit, process, and map the photos and data before creating final reports, ArcGIS shapefiles and geodatabases, Google Earth files, and CSV output. The webinar is going to take about 30 minutes, and there will be a Q&A at the end. Please feel free to type in questions into the Q&A section of your GoToWebinar toolbar at any time. My name is Stephanie Giard, and I will start by giving a short presentation about geospatial experts, as well as our GeoJot Plus field data collection system and its pairing with the TruePulse 200X laser. Steve Coburn from Laser Technology will talk to you about LTI and how their laser technology works. And then Tyler McGarity from Geospatial Experts will be doing a demo of GeoJot Plus with the TruePulse 200X laser. And we will wrap it all up, as I said earlier, by answering your questions. Laser Technology and Geospatial Experts have been business partners with complementary data collection, measurement, and mapping solutions for over 10 years. And now we're working together to provide enhanced measurement and information collection capabilities through the integration of the GeoJot Plus app for iOS devices with the TruePulse 200X laser rangefinders. Geospatial Experts has been the world leader in photo mapping software for business since 2001. In addition to LTI, Geospatial Experts is also business partners with Esri, Juniper Systems, Trimble, and we have a worldwide network of resellers. The GeoJot system that we'll demonstrate here today is the successor to Geospatial Experts' widely used GPS PhotoLink software. End users of Geospatial Expert systems include every federal agency, pretty much all of the states, many regional, local, and foreign governments, most of the Fortune 100, and many universities and NGOs. The integrated GeoJot Plus TruePulse system can be applied towards solving all kinds of problems and towards fostering and enabling new business opportunities. Hole audits, joint use line spacing, and vegetation management are only the start of a long list of applications for a GeoJot Plus TruePulse system. To help you better understand the live GeoJot Plus demo that follows, here's a quick overview of the system's capabilities. So GeoJot Plus is a complete field data collection, mapping, and reporting system. I'll start over here on the left with the GeoJot app running on an iOS device. So you take a photo of an object and fill out a form to provide a short description of the object. And in addition to using drop-down lists and typing information into the form, you can also bring in data via Bluetooth you've captured about the object using a 200X TruePulse laser. This information can include height, missing line, and remote location. Then in real time, you can transfer the data to the cloud and bring it down to a processing PC running a GeoJot Plus Core. GeoJot Core is a PC-based software application that's used to edit the data and photos for quality and then create reports as well as Esri, Google Earth, and CSV files. Not pictured in that last slide is the GeoJot Plus Administrator's Dashboard. So this is part of the entire GeoJot system package, and it allows you to monitor and manage GeoJot Plus activations. This enables team managers to assign, activate, revoke, and reassign GeoJot licenses among mobile workers. And so the app isn't permanently tied to a specific employee or a piece of hardware. And then importantly, GeoJot creates output for any and all end user needs, including shapefiles and geodatabases for ArcGIS systems, output for relational databases and spreadsheets, KML and KMZ files for Google Earth, watermark photos, and a variety of different reports. So those were the highlights of the GeoJot Plus Field Data Collection System, and now I am going to go ahead and hand things over to Steve.
Okay, thank you, Stephanie, and welcome everybody. A little bit first about the company, Laser Technology. We've been in business for over 30 years now in the state of Colorado, hold over 65 patents worldwide, more pending. Some of our milestones are shown here. We developed a speed gun back in the early 90s that was modified for NASA to do their proximity and their docking missions, became standard equipment on all those missions. In mid-90-ish, we partnered with Bushnell to make our first recreational laser rangefinder for hunting and golf, and still developing state-of-the-art products for them today. And later in the 90s, developed the first handheld total station you see pictured there with a combination with GPS, a real important integration into this geospatial industry here. So since that time, we've developed a network of worldwide dealers and distributors in this industry, including geospatial experts. As Stephanie mentioned, for over 10 years with them. And you see a business partner with ESRI, like GSE, for that length of time as well. So a little bit on the background there, and then some of our core technology we see here. When people think of lasers typically for surveying and distance measurement, they think of a phase laser, which is measuring the phase return of the energy, very precise, but has some limitations. It needs a reflector and that kind of thing. Our technology is called pulse laser technology, and it can measure to any type of surface. That's really doesn't matter what the size, shape, or color. It'll depend a little bit on the maximum range you can shoot, but it just has that ability to just measure right to any type of surface. So some of our products in our TruePulse line you see pictured here. The one on the upper right you've seen displayed. That's our new 200X model that has the capability to interface with the iOS Bluetooth modules, so you can get into the iPhones and iPads. But you see the other products displayed here as well. Very simple technology to operate. They're all handheld, lightweight, pocket size. You have in-scope data you see right there. That's the user interface, just a few simple buttons. Very, very compact and easily integrated into data collectors and things like that, like the mobile platforms. We have 200 models that measure just distance and inclination, and then 360 models that offer the electronic compass and more flexibility and stuff. And then, of course, that 200X with the new iOS capability. Okay, let's settle down here into measuring a distance. So this is the simple core function of the lasers can provide, particularly the Model 200s. You aim at the object, you press the fire button, it's going to measure the distance to that object if it gets enough signal return, as well as the inclination. So you can see all sides of the right triangle there. Your horizontal distance, of course, critical for mapping, and the vertical distance for attributes or elevation change. And then one of the onboard routines that we offer in the instruments are height measurements. And we can do it one way here with a 3-shot routine, where if you have an upright object like this light pole pictured, and you can sneak a distance into the center of the object anywhere to get that range. You measure that your first shot, and then just 2 angle shots to the top and bottom, and it will calculate a height for you. So it can be a great attribute when you're out collecting data. And then this last image here shows an operator out in the field around some power lines, and that 3-point height routine we showed there, great for measuring the height of that foam pole you see. It's a nice vertical upright object. This is the routine you'd want to use to inventory that pole, for example. However, getting the clearance of the wire over the ground, that's also needed many times. We have what's called a missing line routine on board the instruments, where it's just 2 shots. 1 shot to the wire, 1 shot to the ground underneath the wire, and you look at the resulting vertical distance value in that solution, and you have your answer for clearance. So just a real handy set of products for these types of measurements out in the field, and great integration with the GeoJot software for many of the applications. So that's it for my section. Let's turn it over to Tyler.
All right, thanks, Steve. I'm Tyler McGarity, and I'm going to do the demonstration portion of the day.
Okay, the first thing we're going to want to do is set up the laser in order to connect to the mobile device. So you're going to want to turn on your True Pulse laser, and you're going to hit the mode button until you see BT come up. Now, if it says BT on, like it does over on the right here, you are good to go. If it says BT off, use the directional arrows to turn it to on, and then hit the fire button, and it will take you back into your regular shot routine. Once the laser Bluetooth has been turned on, then we'll connect it to the phone itself. So to do that, I'm going to bring my phone in here, and we're going to take a look. First thing we want to do, you have to have Bluetooth turned on the phone as well. You can see I have the icon here, Bluetooth is turned on. We're going to want to go into settings. Inside the settings, we're going to click on Bluetooth, and you can see True Pulse 200X, it's connected to the laser. So now that I've connected the laser, if it says not connected, then you just click on it and it'll spin for a second and then tell you that it's connected. So once it's connected, then we can go into GeoJot and see that they are working together. So we're going to launch GeoJot here. If we choose to take our first shot of, say, horizontal distance, just to test here, you can see you're getting your lat long coordinates, your GPS accuracy, which is indoors, so not that great, and the direction that we're pointing. Now I'm going to shoot with the laser a horizontal distance across the office, and it's going to come back and tell me that that is 36 feet, which it is listed here. So now you know the laser is working. I shot a shot with the laser, and it went directly into the mobile device. So what do you do out there? If you're shooting an offset asset, let's say you're back from what you are actually capturing, what you do is shoot a horizontal distance measurement just like I did there. That's going to be recorded with the photo. And so in the EXIF data, you're going to have the direction of the photo and the distance to the object. That's going to allow you to move your point, your lat long point, over to the actual asset location when you process these photos through Core. So we're going to show you a little bit of a shooting routine here. We're going to use, as an example, pole survey. So let's say that you had a pole that was in front of you there and you wanted to know the height of one of the attachments or the entire pole itself. What you can do is, in your True Pulse, you'll click through the buttons until you get to that HT. You'll see that right down here. And that will guide you through the shot process. So the first shot you're going to shoot is going to be the distance. Once again, I'll shoot across the office. That gives me 10 meters. So I know what that is. I'm going to take a photo of the asset. We'll say that's a pole. And that'll bring up my form. Form's something that you create in the desktop software. And then you can have up to 80 fields with drop downs and information to be recorded. So let's say I wanted to shoot pole height. I'm going to go into there. It says enter True Pulse reading. I've already shot the distance to the object, so now I can shoot the angle 1 of the object, which will be the next shot here. So you shoot the base. And then after the base, we can shoot the top. And it's going to tell me that distance is 16.57 feet. That's been fed into GeoJot directly there, so I can QC that, take a look at that distance, and then I can select it and say done. And then I can move on to the next object. Now, if I want to go through and shoot the heights of things right away, I could take that pole height, I could go to the next thing and say, oh, my next attachment's a transformer, and it's owned by ABC Telco, and what height is it at? Well, because the first two shots that we took were distance to the pole and the base, we don't need to shoot everything again to get the height of that attachment. we'll simply hit the back arrow once on the true pulse, and it will take us back to that angle 2 shot. Since we've already shot distance and the base, we can then shoot angle 2 to the height of that transformer, and that will tell us exactly what that transformer's height is. And in order to do that, we'll go into the attachment height, and we'll go ahead and shoot that angle again, and then it's going to pop up and say, oh, that's at 9.65 feet. We can go ahead and select that, say done, and we can move on to the next attachment and do the same things. Just hit that back arrow, shoot that second height, feed it right into the software. So that allows you to go through pretty quickly once you've established your initial measurements there, and you can shoot off everything that's on this pole and be ready to go moving forward. Once you've filled out that information, you can save it. It's going to save the photo in the form data, and it'll take you right back to the camera screen where you're ready to go on and take a picture of your next pole and shoot the laser distance. So now that we've gone through and taken a look at that, I'm going to show you quickly core as well, which will involve me downsizing that and then throw the camera off to the side here. So core is the desktop portion of the software. You can see here we have GeoJot core. There's a project manager. It can have all of your projects listed in there, photo count, when it was created, when it's been updated, and access direct links to the different outputs that were created. So this project is a pole survey. When you start out, you're going to be on the import photos screen. This is where you can pick your photo locations and bring them in. Then there's the geotag screen. This allows you to take photos that do not have spatial coordinates with them and tag them with a GPS file. And the data editor screen. So data editor here allows me to take a look at the photo itself. I can see the data that was collected with it, all the data that was collected with it, even fields that are empty because no data was put into those fields. And I can also, from the data editor, look at the map tab, which allows me to see the location of my photos from an overview map. I can zoom in and hover over and see the individual photos. And if I hold down, if I wanted to take a group of them, say, let's say I was more concerned about this smaller group of photos here in the middle, I can hold down Control and drag a box, and it will just highlight those photos and take me to them over here on the left. And then I can look at their data for comparative purposes in the data editor. So the data editor is all of that collected data that you're going to want to use in your outputs. Once again, we talked about the offset location when we shot that. So in here is where you would be able to look and say, oh, I have a photo distance and an offset location, and so all I need to do then to move my point over to that would be to say add offset locations. It's going to calculate based on those points, and then it can move your actual points to the location of the pole instead of being where you were. You can do that for just one, or you can select all and add the offsets for all of them, and it will move them all to location if they all have that data. Okay, now we're on the photo editor tab. So the photo editor tab, it's not a very great poll. I'll move over to this one. Photo editor tab lets you do things like crop the photo. You can add text bars on here if you want to say certain things about the photo. You can circle things, highlight things on the photo. You also can use the measurement tool. So if you have things that weren't measured out in the field, you can measure them back in the office here. In that case, let's say I have this unit, and I know my pole height is 40 feet, but I don't have a mid-com height. So if I go back over here to the photo editor, I can calibrate this tool, go to the bottom of the pole, scroll up to the top of the pole. I can say that that distance is 40 feet. And that will calibrate the pixels on the picture. Then if I want to know that middle com height, I can come over here and use the actual measurement tool to grab that go up to middle com, tells me it's at 26.6 feet, copies it into the clipboard. So if I want to go back over here to the data editor, I can click on that mid-com height and paste in what my measurements were. Then we have the Watermark tab. This is where you set up all the data that's displayed on the picture for your archiving. So here we have the different pole IDs, the lat long. You can put date, time, any information you want. Once you set this up and create watermarked photos, they'll all be watermarked that same way. Shared output is where we get to set up what we want to see on our output tables. So in this case, you know, all the information that I want output, I select here. And when I create output, that is going to be what the table is in this order with this information. And that's the table that's the basis of your shape files or your GeoDatabase or your CSV file. Also the information that will be displayed in your paper reports. You can also set up here the rename photos function. So in rename, what you can do is whatever's selected here in the fields box is what the photo is going to be renamed. So if I want to take everything out of here, it'll just keep the same file names that are listed here in the list. If I want to rename it, I can say, oh, I want to rename it based on these two features, and it will rename the photo when you create your output. Then on the select output, these are all the various outputs you can create with GeoJot, which I will show you here. You got your standard report, which is a photo, watermarked, a couple overview maps, and a data table. And you can have a standard report like that, just to go through and highlight all your pictures. If you had written on these or done anything, you'd be able to see that as well. Also along the paper report side of things, we have a HTML output, which you can set a dynamic map for. So in this case, I can have all these points created as an HTML file. If I hover over them, it'll show me the picture. If I click it, I can go to that picture with the map and the data table as well. So this is an output you can push easily to a website and push up to your web server and have a URL where people can go to and look directly at what's being collected in a project during that day or during that week. All right, and then of course we do the Google Earth output. So here we are, same spot, Google Earth. I can zoom into these and click on them. You can choose the size of the photo here. These are the big ones. Pops up, full resolution, and the data that was collected with it. Also in ARC, similar. Here we have the photos, they're white crosses here. When you install ArcGIS, it'll install this toolbar for core. So if you click on the little camera, you can go hover over the points that you imported via shapefile and then see the actual photos. And you can set up what data you want seen with the photos in the settings portion here. So really easy for you to process all the photos, then get them incorporated into your back-end GIS system like ArcGIS so that you can then see all of your assets in one location and do some meaningful extrapolation there. I will also show you, we do of course the CSV file, still one of the most popular, very simple flat table with all the data that you selected. You can put the CSV file into just about anything. So really convenient there. You have everything collected and you can push it into whatever kind of back-end system you want. I did say I briefly mentioned that I would talk about the form creator. You saw that form that went on out there and when we first took pictures with the mobile device. You can see that the form creator, very easy to use. You can come in here, you add your fields, create a field name, what you want to collect, you know, poll, ID, and you can say whether it's required, you want to allow typing, whether there's a default value, and then you can even put in a description here that will pop up with it out in the field. So I could say, take poll ID from barcode. We do support scanning barcodes in the software as well, so you can scan barcodes similar to a laser there. You can scan a barcode directly into a field and have that data pop right up. So you can create your forms that way. You can also, if you have an existing Excel spreadsheet, in this case the Joint Use Poll Survey. I can import an Excel spreadsheet here, and it'll ask me which sheet I want to use from that. I'm going to use the first sheet, and you can see here all this information that was populated in columns is now filled out over here into the form. So then once I've created this form, I can send it, I can save it, I can lock it so it can't be edited out in the field, I can attach it to an email, or I could drop it in a shared cloud location so that my field users can go out and get it. In the enterprise version of our software, we allow you to sync forms and settings out to the mobile device user, as well as have some more options on what your cloud server is. We'll let you use FTP or Google Drive as opposed to just Dropbox. So that's all license level stuff. I think it gives you a good overview of how GeoJot works with the laser there, and now I will throw it back to you.
All right. So a brief overview of the capabilities of the GeoJot Plus TruePulse system that we just went over. So you're able to capture and manage photographs of your field assets. And so when you're capturing that attribute data, you can capture things from the TruePulse lasers, like remote locations and height and missing line. Then you can take all of that data and have it transferred via the cloud back to your office for processing, where you can do your QA and QC. And then you can create all of different types of reports, maps, and CSV output. And there's also the administrator's dashboard, which allows you to manage your users and turn folks on and off, and so you can move the app around to different mobile devices. So why use the GeoJot Plus TruePulse system? Well, it allows you to increase your revenue opportunities and also increase your efficiency, which helps you to control your expenses and keep your costs down. It also allows you to increase worker safety, not having to go up to all objects or deal with an asset that's behind a fence with a dog. And you can deliver more value to end users and improve your image with your clients. So this slide shows a list of the companies that resell both GeoJot Plus and the LTI lasers, and these are the folks that you can contact to purchase the system. And you can also contact us, or more specifically Tyler, and he can answer your questions or route you to the appropriate person to get answers from your questions with one of our resellers or laser technologies.